Hello class, welcome to classifying matter. Here are the objectives for this lesson. We're going to define and identify the states of matter. That includes defining, comparing, contrasting substances, elements, compounds, and mixtures. Then we're going to talk briefly about two different laws, the law of constant composition and the law of multiple proportions. We're going to define and identify homogeneous and heterogeneous mixtures. We're going to learn how to separate the mixtures, which, by the way, is the basis for our first lab. And we're going to compare and contrast physical and chemical properties and changes. Now, you can find most of this information in Chapter 1 of your textbook. Let's take a quick look at the first state of matter, gas. At room temperature, if that is how they exist, we call them a gas. But if it takes heat to turn something into a gas, it's actually vapor. For example, water at room temperature is a liquid. When you heat it up, it becomes a vapor. Oxygen, however, exists as a gas at room temperature. Gases have no fixed volume, no shape. In fact, they fill the container. They can be compressed, and if you think about those balloons in that picture, you can squeeze the balloon and compress the gas, and this decreases the space between the molecules and increases pressure. Molecules are far apart, they are traveling at fast speeds, and when they collide with each other and collide with the walls of the container, they create pressure. The second state of matter is liquid. These have a distinct volume independent of the container. If you have 50 milliliters of a liquid, it doesn't matter what container you put it in, it will have 50 milliliters. Liquids will take the shape of a container. They cannot be compressed. Molecules are packed closely and they're moving pretty rapidly. And the molecules can slide over one another. Now, if you doubt my ability to compress a liquid, go ahead and put some liquid water in your hand and try to compress it. The last state of matter is a solid. These have a definite shape and a definite volume. Can't compress them. Again, take the top of your table in front of you, try to compress that with your hands. Molecules are held together very tightly in distinct, definite arrangements. But those molecules can wiggle in those fixed positions. In fact, the molecules are constantly just shaking and vibrating and turning, but they can't move anywhere. And if you look at that picture in the slide, you can see the regular pattern in the solids. You can see a little bit more space between the liquids. And gas molecules are kind of like kids hyped up on sugar at a park. They're all over the place. Let's go ahead and define a few more words we find in this unit. A pure substance has distinct properties in composition. Elements cannot be decomposed into simpler substances. Each element is comprised of only one kind of atom. Oxygen has only oxygen atoms. Chlorine has only chlorine atoms. Compounds, though, are substances composed of two or more elements. They can contain two or more kinds of atoms. Think about CO2 or NH4Cl. Mixtures, though, are combinations of two or more substances, and each substance retains its chemical identity. We'll talk about the mixtures in more detail. And this is just a great little depiction of the difference between elements, compounds, and mixtures. There are two laws of composition we need to discuss briefly. The law of constant composition simply states that elemental composition is always the same. This is also called the law of definite proportions. An example of that would be no matter what, you always find CO2, one carbon to two oxygens. The law of multiple proportions confuses kids, and it really shouldn't. It simply states that elements can combine to form different compounds. The elemental ratio is not the same. So in this, you have the same atoms, they just don't have the same subscripts, and they don't reduce to the same subscripts. For example, carbon monoxide, carbon dioxide. They both have carbon, they both have oxygen, but not in the same proportion. CO is 1 to 1, CO2 is 1 to 2. Same for NO and NO2. Let's take a brief look at mixtures, homogeneous mixtures, that HOMO means the same. That means we see a uniform composition throughout. They could be made from solids, liquids, gases, any combination thereof. Examples are air, salt water, and metal alloys. Now, the key here is it is a mixture. That means it's more than one thing, but it seems like just one thing. Really good mixed up chocolate milk just looks like brown liquid, not milk and chocolate. Heterogeneous mixtures, though, clearly you have more than one thing mixed together. You don't have the same composition, the properties, or appearance throughout. Rocks, wood, and cereal are examples. And this picture here are a few more examples. In the homogeneous, you see tea, juice. Now, I would argue juice with the little clumps, that would be heterogeneous, but smooth juice does qualify here. Some of their heterogeneous mixtures, they've got soupy noodles, assortment of nuts, soil, because think about all the stuff you find in soil.
So how do you separate a mixture? There's quite a few different ways, and this by no means covers all of them. The separation technique is going to depend upon the solution. Filtration is simple. You've done this many times. You separate a solid from a liquid, cereal from milk. You can use a strainer. You can use filter paper. In chromatography, and we will do a lab on this later in the year, it uses the fact that not all substances can adhere to surfaces of solids the same. Now, I wish we could do distillation, but we just don't have the equipment. But distillation takes advantage of different boiling points. You heat up a mixture, one's going to boil before the other, and the one that boils first is going to go down that tube and be collected into another flask. Sometimes you can separate based on color. Imagine a jar with blue and red and green marbles. You can separate based on color, assuming you're not colorblind. And density. If something floats, you can pretty easily separate that. Now, our first lab will be separating a mixture, and we'll actually use a combination of some of these in our lab. The last thing we're going to review are physical and chemical properties and changes. Physical properties can be observed without changing the composition. Examples would be color, odor, density, melting point, boiling point, hardness. You're just describing what something looks like. And a physical change doesn't change what you have. Now, the substance might look different, but it's still that substance. If you take paper and color on it with crayons, it's still paper. If you put makeup on somebody's face, you didn't change them into a zebra. If you take paper and tear it all up, it's still paper. But chemical properties, now this is describing how substances can change, how they react to make different substances. Examples of chemical properties would be its ability to burn. And a chemical change means that you no longer have what you started with. You have created new substances.